Hi everyone, welcome to Physics with Ben. This is video 03 on basic electronics or semiconductors. Yeah, the reason why I'm making this video is that examiners love asking questions from this topic. Good. Now, in today's class, we want to look at types of semiconductors. There are basically two types of semiconductors. Now, take note, every video clip I'm dropping here is based on popular asked questions. Okay, number one, we have the intrinsic semiconductors. Then we have number two, extrinsic semiconductors. What are intrinsic semiconductors? Intrinsic semiconductors, they are called the purest form of the natural occurring semiconductors. We have examples, there are just two of them. We have the silicon and the germanium. Now they have a problem. We can increase the electrical conductivity of semiconductors through thermal agitation and through doping. Now, in intrinsic semiconductor, in physics, when forces are balanced, there's no motion. Similarly, in intrinsic semiconductors, the number of negative charge carriers is equals to the number of positive charge carriers, meaning the number of free electrons is equal to the number of holes. For this reason, for this balance of charges, the net flow of currents is very, very negligible. And so we say that in intrinsic semiconductors, the electrical conductivity is very, very negligible. How do we go about it? This is not too good. For this reason, we'll have the next type of semiconductors, which we call the extrinsic semiconductors. In extrinsic semiconductor, what are they? These are artificial or impure forms of semiconductors. They are gotten by doping silicon or germanium with pentavalent or trivalent dopants. Now, what is doping? Doping is simply a chemical process that is deliberately carried out to unbalance the charge carriers in intrinsic semiconductor so that there will be net flow of currents. Now, in extrinsic semiconductor, the number of negative charge carriers is not equals to the number of positive charge carriers, meaning the number of holes is not equals to the number of free electrons. For this reason, the electrical conductivity in extrinsic semiconductor is higher than that of intrinsic semiconductor.